Hey there, welcome to our fourth part of Git and GitLab tutorials for beginners series. As till now, we have got to know about the creation of local Git repository that is in our local system and how to add the files from modified area to staging area. Now, we shall learn how to add those files in staging area that we did in the previous video to committing area and how to undo those changes. So, let's get started right away. I am Abhiram BJ, speaker of Clue, which is one of the FOSS community. Do like this video and subscribe to our YouTube channel and press the bell icon for the latest updates. As in the previous video, we have added the files from modified area to staged area. Let's check its status in Git by using the command git status. Now, as you can see, the files are depicted in green color. That means the files are in staging area. Let's add these files to committing area to save the changes to Git. Before doing it, we shall recall the definition commit that what we described in the second part of our series. Commits are the heart of the Git usage. You can think of a commit as a snapshot of your project where a new version of that project is created in the current repository. You can recall the committed changes at a later date or revert the project to that version. If multiple commits edit different parts of the project, they will not overwrite each other even if the authors of the commit were unaware of each other. Now, as the files are in staging area, we can add these files into committing area easily as it follows the sequential stages of Git that we described in our previous video. We can commit the files from staging area to committed area with the message that describes the changes you are committing by using the command git commit -m. In the double quotes, you enter the description message. This command captures a snapshot of the project's currently staged changes. Committed snapshots can be thought of as the safe versions of a project. Git will never change them unless you explicitly ask it to do. If you see the output of this command, you can see that the commit ID is appearing there. We will look into it in a while. Now, as we have committed the files to Git, let's edit these files and again we shall commit it. First, let's write some context into the index.html file. Now, if we check the status of the file by using the command git status, we get to know that the file has gone to modified stage. Now, we should again follow the sequential stages of commit. That is, first we shall add this to the staging area and then we can make the commit. Now, if we see the prompt, the commit ID is changed and the number of files are changed and the number of lines inserted are displayed. Next, we shall make the same changes to the style.css and commit it. Now, if we notice the output, when we commit the two files, we get two different IDs for two different commits of a same file. And there is a specification of number of files we changed, number of insertions done and number of deletions done that we made at a particular commit. In this way, Git stores every version of the files that you commit and keeps track of these changes. Till now, you have created several commits. You probably want to look back to see what has happened. To look into the commit history, we use the command git space log. This command lists the commit made in that repository in a reverse chronological order. That is, the most recent commit shows up first. As you can see, this command lists each commit with its SHA-1 checksum, the author's name and email, the date written, and the commit message. To obtain the only commit ID and its message, you can use the command git space log --one line. Here, if you see this line, this says that at which point you are working in your repository. Up to this point, we have seen how to commit the changes you made to the Git. Now, we shall look into how to undo the changes. But before moving into this, let's get to know about the three types of commits that are used to undo the changes. Firstly, checkout commit. Checkout is used for the act of switching between different versions of a target entity. It checks the branches and updates the file in the working directory. And it also matches the version already available in that branch and it forwards the updates to Git to save all new commit in that branch. Sometimes this command is completely safe. Next is revert commit. The term revert is used to revert some changes. It does not delete any data in this process. Instead, it will create a new change with the opposite effect and thereby undo the specific commit. Generally, git revert is a commit. It is be useful for tracking bugs in the project. This prevents Git from losing history, which is very important for the integrity of your commit history and for reliable collaboration. The next type of commit is reset commit. This undoes the commits by removing previous commits from the repository and resetting the Git head to an earlier commit. Some Git history might be lost by doing this, depending on what option is used. Git reset can operate on a whole commit object or at an individual file level. Each of these reset variations affects specific trees that uses Git to handle your file and its contents. As now we got to know the theory of undoing things. Let's practically apply this and let's get to know in a better way. Firstly, let's look into the Git checkout. To check out a specific commit, run the command git space checkout space your commit ID where you have to go back. This makes your working directory match the exact state of commit ID. You can look into these files, compile the project, run tests, and even edit files without worrying about losing the current state of the project. Nothing you do in here will be saved in your repository. To continue developing, you need to get back to the current state of your project. Git space checkout space master. This assumes that you're developing on the default master branch. Once you're back in the master branch, you can use either git revert or git reset to undo any undesired changes. If you need to find the ID of the commit you want to see, you can use the command git space log -- one line. You will see the commit ID of the recently changed ones and the message. Next, we shall look into git revert. The command used to git revert is git space revert space commit ID. This command is used for undoing changes to a repository's commit history. A revert option will take the specified commit, inverse the changes from that commit, and creates a new revert commit without deleting the previous ones. The reference pointers are then updated to a point at a new revert commit, making the tip of the branch. We can now examine the state of the repo using git space log -- one line and see that there is no new commit added to the previous log, or there is commit added to the previous log. Next is git reset. This command git reset space commit ID sets your branch state of a particular commit. This only updates the index, leaving files in your working directory unchanged as if you had made the edits but not yet committed them. When passed -- hard, the commit history reference pointers are updated to a specific commit. Then the starting index and the working directory are reset to the match to that staging index, and the working directory gets reset to the match the state of the commit tree. This means any pending work that was hanging out in the staging index and the working directory will be lost. The command used here is git reset space commit ID -- hard. Here we have executed a hard reset using the -- hard option. Git displays output indicating that head is pointing to the latest commit. Now we can look for the commit history of the commits done by using the command git space log -- one line command. So now we have learnt about the different ways to undo these changes in Git. That's it for this video. In the next video, we will be looking into creating branches in our working repository. Do like this video and subscribe to our YouTube channel and click the bell icon given below for the latest updates. Thank you guys. Happy exploring. Let's meet in the next video.